The UK strawberry industry is worth over £380 million annually, yet it faces a crisis that no amount of good weather can fix. Rising labour costs, chronic seasonal worker shortages, and razor-thin profit margins are pushing farms to the brink. Under the UK's seasonal worker scheme, 38,000 visas were made available in 2022 against an industry need of 70,000, and the gap is widening every year. For a strawberry farm to stay profitable, at least 90% of ripe fruit must be successfully harvested. Leave any to rot and disease spreads, risking the entire crop. The margin for error is almost zero. Robotic harvesters have been proposed as a solution, but existing systems struggle with the real-world complexity of the job. Strawberries may be hidden behind leaves, growing in tight clusters, or tucked beneath planting pots. After visiting the New Forest Fruit Company and reviewing the latest research, one thing became clear to us. The defining challenge isn't picking speed, it's picking success rate across every age case.
This is Robotic Strawberry Harvester. Developed to tackle exactly that challenge, our system combines a 5 degree of freedom robotic arm with a custom cut and grip end effector designed specifically to maximize picking precision when harvesting strawberries in clusters. The hook and blade mechanism applies precisely controlled force, keeping bruising to a minimum even in confined spaces.
At the core of the harvesting process is an RGB depth camera, which detects ripe strawberries in real time using a YOLO machine learning model. Once a target is identified, a Python-based program calculates the joint angles required to position the arm and sends them directly to an Arduino microcontroller. The arm navigates to the target fruit, drawing on inverse kinematics to ensure accurate, repeatable positioning across the full workspace.
Once in position, the arm performs a wrist rotation sequence, capturing images from 5 different angles. This is critical for edge cases where the stem is partially hidden or awkwardly oriented. By scanning around the fruit, the system reliably identifies a precise picking point even when direct frontal view isn't enough. After locating the stem, the end effector moves into place, engages the hook, and draws the stem against the blade, cutting and gripping in a single controlled motion. The strawberry is then transferred cleanly into a collection box.
By combining multi-angle inspection with precise actuation, our system is built to handle the challenging scenarios that defeat conventional harvesters, delivering reliable picks even when the fruit is hidden, clustered, or difficult to access.
We have successfully completed all unit tests for the components of the system, from computer vision to arm movement, demonstrating that reliable, high-precision robotic harvesting is achievable, even in complex picking environments. Future work will focus on 3 areas: improving detection and cycle speed, verifying performance in real growing conditions of strawberry farms, and scaling toward a full system, with the ultimate goal of delivering a commercially viable solution to one of British agriculture's most pressing challenges.
With that, thank you for taking the time to look at our project.